All right, let's just dive right into this explainer. Today, we're taking a road trip, billions of miles across the universe, to check out some of the most unbelievable planets ever discovered. We're talking worlds that completely challenge how we understand the cosmos. From planets hotter than stars to those colder than ice, the sheer, wild diversity of exoplanets out there is forcing us to rethink basically everything we thought we knew about how planets form. Okay, picture this. It's totally mind-bending. What if, floating somewhere out there in the pitch-black void of space, there was a planet made literally entirely out of diamonds? Just a whole world shimmering out there, holding wealth that is completely beyond human comprehension. Or hey, what about a world swallowed by oceans so deep they make the Mariana Trench look like a puddle, plunging down into total darkness with crazy, crushing pressure at the bottom? I mean, it sounds completely like sci-fi, right? But these places actually exist. So here's the game plan for today. We're going to start with some extreme and bizarre worlds, then swing back to our cosmic neighborhood, and finally wrap up with the ultimate search for Earth 2.0. Kicking things off with Section 1, Extreme and Bizarre Worlds, let's look at the universe's most shocking discoveries. All right, meet 55 Cancri E. Thanks to a wild mix of incredibly high carbon concentration and just immense pressure, scientists actually think a huge chunk of this planet is solid diamond. Literally. We are talking about a world whose theoretical value would instantly crash every economy on Earth. Basically, the carbon-rich environment acts like a massive cosmic pressure cooker, turning what would normally just be graphite or soot into a dense, crystalline diamond interior stretching for thousands of miles. Pretty crazy, right? Well, hold on, because there's a pretty massive catch. The surface temperature of 55 Cancri E is a staggering 3,600 degrees Fahrenheit. Yeah, that is hot enough to melt metal. So this diamond world, it's an incredibly hostile, lethal environment. At those temps, the surface is probably covered in this thick, oozing layer of molten carbon, basically lava, meaning any probe we send to extract that cosmic wealth would incinerate instantly. And speaking of hostile, this next one perfectly shows how looks can be totally deceiving in space. HD 189733b looks like a gorgeous, calm, deep blue world. But that color doesn't come from water. It comes from an atmosphere laced with jagged silicate particles, essentially blasts. The way starlight scatters through these silicate clouds gives it that peaceful, azure hue, which is a total lie because it completely masks the incredibly violent weather happening just under the surface. How violent? Well, those glass particles get caught in winds whipping around at 5,000 miles per hour. That is 7 times the speed of sound. So you've got these perpetual sideways glass storms. It is an absolute nightmare of a climate. Anything entering that atmosphere wouldn't just be blown away, it would be shredded to dust in seconds by a supersonic barrage of razor-sharp silicates. So yeah, a beautiful color palette absolutely does not equate to a welcoming world. Okay, let's swap glass storms for endless water. This is GJ1214b. Scientists suspect this mysterious giant has zero landmass. None. It's completely covered by a global ocean. And the pressure at the bottom of an ocean this deep is so unimaginably intense that water might exist in exotic states we almost never see here on Earth. Deep down in the pitch black, you wouldn't find normal ice. You'd find something called Ice 7. It's this weird, dense, hot form of crystalline water forged not by temperature, but by pure, crushing gravitational pressure. Now, usually a planet's shape is controlled by its own gravity, right? Well, WASP-12b completely breaks that mold. This gas giant orbits so incredibly close to its host star that the star's immense tidal forces are actually stretching the planet into an egg shape. It's literally being torn apart. The star pulls so intensely that superheated gas is constantly siphoning off the planet, streaming into the vacuum of space and creating this glowing bridge of doomed material. And because it's being continuously stripped like this, WASP-12b isn't going to be around forever. Like researchers have pointed out, we are witnessing a planetary death in real time. It's just a brutal reminder of the violent, dynamic forces at play out there in the cosmos. In a few million years, which is a total blink of an eye in astronomical terms, this entire gas giant will be completely devoured, leaving behind nothing but a quiet, empty orbit where a massive world used to be. All right, let's take a breath and move to Section 2, our cosmic neighborhood. We're heading back closer to home to check out our own solar system. We've got to start with the big boss, Jupiter, our solar system's gravitational anchor. Obviously, everyone knows about the Great Red Spot, but Jupiter plays this crucial role in keeping the inner solar system stable. Its immense gravity acts like a giant cosmic shield, deflecting or absorbing comets and asteroids that could otherwise pose a huge threat to Earth. By basically sweeping our orbital neighborhood clean of cataclysmic debris, this gas giant has quietly given us the stable environment we needed for life to evolve and thrive over billions of years. And just to put that scale into perspective, you could fit over 1,300 Earths inside a single Jupiter. Over 1,000! It's so humbling when you see our tiny, fragile homeworld put up against a gas giant like this. When you think about the sheer mass it takes to hold in those raging storms, the metallic hydrogen oceans, and those crazy powerful magnetic fields, you realize Jupiter operates on a completely different physical scale than the rocky little planets we're used to. Moving outward, we hit Saturn. Famous, of course, for those incredibly magnificent yet surprisingly thin rings stretching hundreds of thousands of miles. But get this, recent data shows this beauty is actually fleeting. Saturn is actively sucking its own rings inward in a phenomenon called ring rain. Yep, millions of years from now, Saturn might not have rings at all. The icy particles are getting ionized by the sun's UV light and dragged down along the magnetic field lines right into the gas giant's upper atmosphere. Then, of course, there's Mars. We know from ancient riverbeds and frozen polar caps that it used to be a wet, really active world. Fast forward to today, and it's the primary focus for our rovers searching for ancient biosignatures, and honestly, our most viable candidate for a future human colony. It represents the ultimate first step toward us becoming a multiplanetary species. Sure, the hurdles for terraforming or building self-sustaining habitats are monumental, but that rusty, iron-rich soil is absolutely the most promising blank canvas we have for expanding beyond Earth. Which brings us to Section 3, the search for Earth 2.0. The ultimate quest to find truly habitable worlds. So, when we're evaluating candidates for a second Earth, 3 exoplanets really stand out from the pack. You've got Kepler 452b, about 1,400 light-years away, often called Earth's older cousin. Then there's TOI 700d, which is an awesome Earth-sized find. And finally, Proxima Centauri b, our closest exoplanet neighbor. The key thing uniting them, they sit right in their star's habitable zone. Tracking these specific candidates gives astronomers invaluable data on just how common terrestrial rocky planets might be across the wider Milky Way. And that habitable zone, the Goldilocks zone, is the critical marker. For a planet to be a true Earth 2.0, it ideally needs to orbit a sun-like star at the exact right distance to allow for liquid water on its surface. Meeting those criteria is step 1 for finding a world that might support oceans, an atmosphere, and potentially biology. If it's too close, the water just boils right off into space. Too far, it freezes solid. Finding that perfect orbital balance is the holy grail of modern astronomy. And that's exactly why Proxima Centauri b is so incredibly significant. It is just over 4 light-years away. In cosmic terms, it's sitting right on our doorstep. Yes, it's still vastly distant for the tech we have today, but it represents humanity's most realistic target for an interstellar probe. If we're going to find neighboring life, this is the system where the search begins. There are already breakthrough initiatives conceptualizing light-sail spacecraft that could theoretically make the journey within a human lifetime. That is turning science fiction into tangible exploration. So, from massive worlds squeezed into solid diamond, to screaming sideways glass storms and the tantalizing promise of Earth-like candidates, the universe proves to be far more dynamic than we ever imagined. Every new telescope brings our place in the cosmos into sharper focus. So, I want to leave you with this. Out of all the extremes we explored in this explainer today, which planet amazed you the most? Think about that as you continue your learning journey. Thanks for hanging out with me.